Okay, let's wrap up the head rig. I have only the head joint not hidden. That means I have only the head that is not being rigged. Let's start with doing the gel here. All we have to do is have a circle controller. Let's call this one AC gel and group it. Call this one AC gel GRP. Okay, now grab the group and then the gel joint over here. And I guess you know what to do, right? Let's go to modify, match transformation to match it there. Now let's grab the controller again, and you see now it's right on the joint. We can grab the vertex out and just to move it to where the gel is. Okay, and then give it whatever shape you think it's proper to represent a gel controller. I'm just gonna give it some sort of curvature like that. Should be good enough. Okay, so that's the gel controller. To make it control the gel, all I have to do is use the controller to do a OR constraint on the joint. Okay. Or you can try to use the IK way there. I think that's redundant, so I'm gonna go for the easy way here. Just use the controller to do the gel joint. Let's do rigging constraint, OR constraint. I don't need maintain offset. Let's do apply. Now if I rotate the controller, I can control to the gel joint to make the mouse open. Alright, now let's move on to the tongue. I'm just gonna select the tongue joints. The second one there, I don't need this first one actually. And let's also select the gel controllers group to isolate those two things. I can then duplicate the gel group and then shift select the first tongue joint here. Let's do another match transformation just to match it to where the joint is. You see now it's over here. The reason for that is because we did move the vertex when we were creating the controller here, right? That's why it's offsetted. All we have to do is holding down B button to oops, let's go to the object mode. Oh, not cool either. Maybe that. No, damn it. Let's try to use component mode. It's also doing that for me. Anyways, I'm just gonna eyeball it then to move it back. Let's use word. I'm not sure what happened there either. So it's gonna drag it back. Looks like I'm using a different way of move to. What we can do is double click on the move to settings and reset the two. And holding down V to move it back. Okay, cool. Now I have this. I can also reshape it to whatever I want it to be. Like that. Okay. Now for this one, I probably wanted to name it AC. Let's see, this one will be named AC tongue 01. Okay, and then rename the children AC tongue 01. Oh, that one will be renamed AC tongue 01 GRP. Okay, let's grab the group and then the next joint. Oh, sorry, duplicate this group. Let's duplicate it, 3 times. So now we have 3 more controllers, and let's rename them to 02, 03, and 04 for those controllers. So that's 03, and that will be 04. And let's just drag the 04 and parent the 04 to 0. Oh, before we do that, let's also match them. So 02 will be matched to that joint. Let's go to modify match all transform, just to move it there. feels like it's tilted. I'm gonna rotate the pivots, the points back. Anyway, so now let's go grab the 0,3 and then match it to the next one, and 0,4 will be matched to the last one there. I really need to rotate them like that. Okay, now I have those controllers, and I have those joints to make the controller control the joints. I guess you know what to do, right? Let's select the controller and then the joint. Let's do a constraint, orange constraint for now. Okay, maybe later on I may want to change that to parent constraint if we're gonna make the tongue being able to stretch, probably, but let's stick with orange constraint for now. So orange constraint from controller to joints. When that is done, I also need to parent controller back to the hierarchy they have to be. So 0,4 underneath 0,3, 0,3 underneath 0,2, 0,2 underneath 0,1. Now I have a hierarchy like that, just like the FK, the generic FK system we will have. Okay. Let's just keep things simple for now. So that's the tongue controllers. To make the tongue controller follow the jaw, just parent the tongue controller to the jaw joint, to the jaw controller. Okay, just middle mouse drag it down there, and then if we open the jaw controller, we can open the entire mouse, and then we have those individual ones to control how the tongue behaves. Okay, so that's the tongue controller. Let's move on to the eye. For the eye, first of all, I need IK handles on it, so let's just go there and create the IK handle. The IK handle will be a single chain here, not rotate plane, because we really don't need that. So something like this would be nice. Let's call this one IK handle left eye, and the other one will be the same thing. So skeleton IK handle. This one will be called IK handle right eye. And then when I move the IK handle, the eye will always be looking at it. Now I just need to create controllers to control those. Let's go to create inner-base primitives circle. Okay, and let's call this one AC left eye, and then of course group it. And then that one will be matched to this joint right here, not the locator, the joint. So let's match transformation, and then I probably want to rotate it, rotate the vertex 90 degrees to, you know, make it look more like a controller for the eye. Maybe scale them up. When that is done, let's duplicate this one and holding down V button to snap it to the other side. This one will then be renamed to AC right eye GRP. Alright, now I also need a overall controller here. So let's select either one of those two, duplicate it, go to front view and holding down X to snap it to the center line, and then I can rename this one AC I. For ACI, I want to make it bigger, so let's grab all the vertex and scale them up, and then maybe model this one like that. Those two will probably be scaled in, and for those two vertex on the outside, I'm gonna make them bigger. Okay, good enough. Now that's the overall controller. To make the controllers control the thing, the eyes, all I have to do is parent IK handle. So this IK handle will be underneath the AC left eye. the right eye AK handle will be underneath AC right eye, and then both AC left eye and AC right eye will then be moved to ACI. Now I can then drag the ACI to control both eyes, and then I can also use these individual controllers to control their corresponding eyes. Yeah. And then when that is done, I believe now I can start cleaning things up. I don't need to see the IK handle here, so just add those two. And then I also don't need to see the joint anymore. Let's organize this. I already have the head joint underneath one group, which is called JT head group. Let's also group all the controllers. Let's call this one AC head GRP. And then select AC head GRP and JT head GRP. Let's group them together. This one will be called head rig. And then head rig will then be moved and underneath AC master mover. Now if you try to rotate the neck now, you see those controllers are not moving with it. There is a very easy fix. All we have to do is first let's delete the parent constraint we did before on the group of the head joint. Let's do a parent constraint. Instead of doing that on the joint, let's do that on the entire head rig group. So select the neck controller and then the head rig group. And let's do a parent constraint. Okay, when that is done, if you now rotate, everything will move. Okay, sweet. Now let's start cleaning things up. I don't need to see the joint anymore, so the JT head GRP will be hidden. And then let's just check. We have another AK handle here. I don't want to see it, so add it to probably that curve also, so add it. I have those IK handles I don't need to see also, so let's just add them all together, leaving only controllers and geometry there. Okay. Now one more thing I want to go over is that the volume controlling thing. In reality, when we stretch something and make it longer, it will become thinner, right? But we don't have it here. All we have is only scaling the joint to make them longer. So let's do the volume maintaining functionality on the span. Go to window and then node editor. Let's clear everything. I need to do that on the span, so I probably need to go to the torso rig and then show all the joints. And then that's the span joint chain. I'm gonna grab each one of those and then show their connection. Actually, I only need to show their input like that. Now if you take a look at it, I don't know what are those. Let's get rid of those. Now if you take a look at those, they are actually very simple. They're just being scaled based on how much the AK curve has been stretched. I'm just using the multiply divide to divide its original length, right? Now I also need to scale the other two axes, Y and Z here. For this joint is X and Z. Anyways, I need to scale those other two axes, scale them down when I'm stretching it. Like when I stretch it up, right? I need to also scale the other two axes to make them go down. That way I maintain the volume. So to do so, I need to know how much I should scale them. First, I need to create another multiply divide, and then this one will be renamed multiply divide scale x square root. Okay, use this multiply divide node. I'm gonna try to calculate the square root of this output x, which is actually the scale x of those joints, or the stretching amount of those joints. I'm gonna calculate the square root To do so, I'm gonna change the operation to power and power it by 0.5. That will actually give me the square root of the scale x, or the stretching amount. Now, after that, I need to create another multiply divide node, and this one I will name it invert scale. Okay, and for the invert scale, I'm gonna use 1 to divide it. So let's just double click it and use 1 to divide the result I'm getting from the square root of scale x. So divide. Oh, sorry, not that one. That's actually the first one there. The second one will be using divide. I'm gonna use input 1 as use 1 for input 1x. That way I'm getting the square root of the scale x I use to apply the stretching, right? I get the square root of that value, and then I use 1 to divide that value, and the result will be my scale of the other two axes. The reason I need this square root is because I'm applying it on other two axes, right? So I need to do the square root instead of just reverse it using this invert scale. Knowing that, all we have to do is use the output x here to connect to the other two axes. Okay. Let's do it here too. That one, and then the other one. Okay, last one here. Now if you take a look at it now, our body becomes thinner when we stretch it up. If you stretch it very long, it's gonna be really thin in the middle. Okay, that maintains the volume for us, which is kind of cool, right? Now sometimes we may just want it to be not shrinking when we drag it up. You see, that looks cool, but sometimes we may want it to be just even, to have a better shape there. So I need to somehow have the ability to control it. Okay. So instead of having the square root of x being applied directly here to do the divide, let's create a blend color. Let's call this one blend color volume maintain. Okay, and then for the volume maintain, let's see. Let's drag the output x here to color 1 from the square root x, and then color 2, let's just go to the channel box. Let's make color 2 1. Okay, and then let's drag the output r to the input of the invert multiply divide. Let's see what that happens. Let's drag it up. Still shrinking, but let's go there and check the blend value here. If I make the blend value all the way up to 1, then we're having more shrinking, right? If we go back to 0, we get rid of it. It's because the blend color is just blending two colors. If it's 0, it's gonna go use color 2, and color 2 is 1. So this will calculate 1 divided by 1, which is 1, so no scale YZ or no other scales there. We're only stretching it, not making the middle part shrinking. But if we change the blender to something bigger, like 1, then it's gonna output color 1 R, and that value is actually the inverse scale calculated, the square root of x here, and it will be used to calculate a different inverse scale, which is the one we needed to maintain the volume. So with that, now I have this blend color that can actually giving me control that do I really want to maintain volume or not, right? By changing the blend color, blender value there. So in that case, all I have to do is grab the controller of my chest. I'm gonna use that one. Oops, where is my stuff? Okay, it seems like I lost my channel box somehow. It's kind of weird. Let's go to attribute editor then. Let's go zero out the translation. Okay. Let's go there and go to attribute, add attribute, and then I'm gonna add a attribute for it, which is called the maintain, the volume maintain. And the minimum value will be 0, maximum will be 1, will be 10 here. Let's just press add. That will give me a new attribute on this controller. And now let's get it in by press this plus button to move it to the node editor. Now I can use the volume maintain to control the blender here. Okay. With that, now if I have the body dragging up, I can use the volume maintain to control do I need more stretching or not. Oh, sorry. I think that's working from 0 to 10. Actually 1 is the proper value, but we can go further than that if you wanted to, but you know. So probably 0 to 1 is a better choice, but higher value can just make it even more dramatic. Okay, I guess that's it. That's the stretch, that's the volume maintain we can have on the spine. You can also apply that on the neck too if you want it. But anyways, something to know about, and then let's move on to more another topic here. If I try to scale my I think I have something wrong here too. My two tooths, my upper teeth and my lower teeth, I think they're not following correctly. That's because I was only using the parent constraint to control them, and we all know that parent constraint, if you take a look at the group now, the parent constraint only controls translation and rotation. So when I scale my master mover, they will not become smaller. They're only gonna move with the joint. So that's not cool. Let's go select those two parent controllers, parent constraints, and then delete those two. And what I really need to do now here is that I need to actually rig them. So let's go to the head rig and show the joint. Let's select the lower teeth joint here, and then the lower teeth geometry. Let's just go to skin, band skin, and I'm gonna use selected joints and then apply. The same thing happens for the upper tooth, and that upper tooth will be banded with the head joint right here. Okay. Now if I do that, I can now try to scale my model. Okay, but there's a problem. If you go to here, you see that when I scale the model, the span here is shrinking. The more I scale it, the smaller it's gonna be. Right, that's not cool. But there is actually a very easy fix. The reason for that though is because if we go back here, see, I don't need those nodes, so get them out. Oh, those. I don't need that either. So the problem for that is because of this, the joint stretching node. When we shrink the master mover, because the curve shrinks with it, so the curve's length changes, right? But the problem is that this multiply divide node is still dividing the original length, which is not correct anymore. This value should be updating or become smaller when we scale the master mover down, right? So I need to compensate that or normalize that value. To do that, the easiest way is let's go grab our original spline curve, which is that one. I'm not sure why I have another one there. Let's go duplicate this original spline curve. Let's call this one normalization, or just NM. Okay. For this one, first I want to go for is go there and find its translation node and check on inherent transform. Check that back on. Okay. Another thing is I need to also, let me just duplicate the curve info here. I need also to measure its length. So this one would be actually called original length. And I'm gonna measure this one's length. You can press forward to show the input curve input, and I can just drag the workspace to input curve, and then now this arc length will be input 2 instead. It's still 18 here, but now if you scale the master mover down, see that it's not making that problem, not having that problem anymore. That's because now this one shrinks with master mover, right? That's why we have to check inherent transform form on. But because this one now shrinks, this new one we duplicated shrink with master mover now, so its curve length actually will be updating with the master mover. So no matter how we scale the master mover, we will also have the right original length to divide. Okay, that's a easy fix. Okay, let's go grab the master mover and then get it back to 1. And also let's also go there and add the joint group. I don't need to see that one either. Okay, now that fixed the scaling issue. Now we can scale, we can rotate, scale, rotation, they all work. Okay, let's go back and then figure out some of the color codings. Normally we want to color coding the middle part as a yellow color. Some people code this one. Go back to 1. Some people color coding the master mover into a particular color here. We can go to display and then go to drawing override and then enable override. And what they do is they actually change it to a color more like how this one. I really don't like this because this color is the same as the thing looks like when you select something. For example, I select that. You see that color is identical with this one. So it's really confusing. Am I selecting the master mover or not? Right? That's not cool. So I would like to keep it, make it a yellow color here. So something like this. If you do that on the translation node, it's gonna change everything, including the joints, which is also not cool. I just wanted to change its color itself. To do so, I have to actually go to the other one, the shape node, and then go there and check object display, check drawing override, and enable overrides. Now this one, if I change it here, oops, you see now only the controller itself changes. It's probably better because I only want the animation curves, but everything is underneath AC Master Mover. If I change the translation node of AC Master Mover, then everything underneath it, including those joints and all of those other elements like clusters, IKs, they're all gonna turn yellow, which is not cool either. So that's the Master Mover. Let's go to the torso center of gravity controller. Let's also make that this one. For this one though, I'm gonna go for the translation node. If I do that here, I make them all yellow. They're gonna make everything in the hierarchy yellow. For those two though, they're supposed to be different. For the left side, we usually use a red color. For the other one, we use the blue color here. So yellow, red, blue, the 3 basic color. Okay, this one, let's use yellow. That one is also yellow. That one too is yellow. and then that one will be a red color because it's the left side. The other one will be blue. Okay. Now let's take care of all the limbs, and for the arm here, all I have to do is find the AC left arm group. That's the group that has all the ACs, all the animation controls. If I change that group into a red, then everything underneath it will be red, including both IK and FK system. For the finger, it's the same thing. All I have to do is locate the AC left hand GRP and then change that to a red color here. Let's go back and do the same thing on the other side. So the AC right arm GRP will also become something else. This time it's gonna be blue, and then the hand is the same thing. AC right hand GRP will turn blue also. Let's go back to the leg. Same thing here, the leg. Find the AC leg GRP. Let's make it red, and the other one, the other side, will be blue. See how fast that is? We can then color coding every controller here. They're all done. And I guess that's it. That's for everything I went over in today's class. We're actually having a lot of things there, so I hope you guys understand everything I went through here, and that's actually all the body setup we need to do here. You guys should be very, very happy now if everything is working on yours. Let's holding down Shift and open the AC Master Mover. You see how many things are there? Joints, controllers. Right? Everything here, you have literally touched everything here. You name them tediously, right? And then you also put them into their very organized hierarchy. So you should be proud that you actually did this. Now, after this class, we will move on to facial expression. Okay, so it's gonna be more interesting.